there are situations where you need to detect and alarm a high overvoltage using your Arduino board. This tutorial covers exactly that use case. This method uses simple Zener diode with some resistors and a cheap NPN transistor. We need an Arduino compatible 5-volt digital signal that can detect and raise alarm for high overvoltage. It is safe to connect to Arduino as high voltage side is physically separated from low voltage side. The design is completely proven and there are only two variables. Zener diode selection. Zener current regulator resistance selection. Everything else including the resistors and transistor are fixed value. You may use any general purpose NPN transistor. Design is compatible to be used by any 5-volt compatible Arduino or any other microcontroller board. Circuit needs external 5-volt supply which is provided by Arduino. Let's take a real-world example. Let's make an overvoltage alarm system which can detect anything over 25 volts. First step would be to choose Zener diode. Select a Zener voltage which is 1 volt less than the maximum allowed detection voltage. In this case, we choose a 24 volt Zener diode 1 volt less than the target voltage. Second step would be to calculate Zener regulator resistance to allow for required minimum Zener current plus the minimum transistor base current to flow. Remember, total current through Zener in this arrangement is sum of Zener current and the transistor base current. We shall be using general purpose 2N3904 NPN transistor for this example. Let's select the right Zener diode part. My personal selection is this case is again BZX55 series, which has excellent electrical properties and comes in compact axial package. This series has an average Zener current of 5 milliamps and we need a 24 volt series diode. BZX44C24 is the correct part for this application. Let's crunch some numbers. As stated earlier, high voltage detection is over 25 volts. We choose Zener voltage as 24 volts, which is 1 volt less than the high limit. Target current must be greater than 5.1 milliamps, but we have still to control it to limit power loss and heat. As mentioned earlier, the total current is sum of Zener plus the NPN transistor base current. We choose Zener current regulation resistance as 3.9 kilo ohms, which is a standard resistor value. Current total comes out to be 6.4 milliamps, which satisfies the criteria, as it is greater than 5.1 but not by much. For NPN transistor collector current, we choose it arbitrarily 1 milliamps by choosing collector resistance of 5 kilo ohms. We know already that base current must be greater than 1/10 of collector current to put NPN transistor in saturation to work as switch properly. If you wish, you can watch my NPN transistor video tutorial for details. We know that 1 volt is applied across the base of NPN transistor and 0.7 volts is the base to emitter junction voltage. Base current comes out to be 0.3 milliamps. More accurately, total minimum current comes out to be 5.3 milliamps, which is less than actual 6.4 milliamps. We now analyze the circuit for various voltages and logic state at the digital in at Arduino. You shall notice that at 10, 20 or even 24 volts, the Zener is not conducting and NPN transistor is off, hence digital in records 5 volts or logic high. As soon as voltage exceeds 25, the Zener starts conducting and NPN transistor saturates, meaning 0 volts or logic low is recorded at the Arduino. Your support is vital. Please don't forget to like and subscribe.